All right, here we go. Here's our select practice problems. Now, all these problems are going to basically revolve around the three new Pythagorean trig identities that we went over today. So we've got sine squared theta plus cosine squared theta equals 1. This is like our starting one. And from that one, I can derive both of these. All right? So remember that the cotangent lines up with the cosecant because they both have sine in the denominator. And similarly, tangent and secant are in the same one because the same equation identity because they both have cosine in their denominators. And so if you can remember that, you'll be in good shape. All right, so let's get started. So we have sine of theta times this. Well, hopefully you recognize this as this, right? You see this and you go, oh, that looks familiar. That's because it's right over here. So let's rewrite this using cosecant squared. All right, so cosecant squared theta. All right, now let's rewrite cosecant squared theta as 1 over sine squared theta, right? And then hopefully you'll see that, oh, I can cancel this one out, and then I can cancel one of these out, leaving you with 1 over sine theta, which is cosecant of theta. So yeah, you need to know your basic identities in order to do this. And the two main ones you got to, or the four main ones you mainly got to remember is you got to remember that cosecant and secant are both reciprocals of sine and cosine, respectively, right? And then you just got to remember that your tangent is sine over cosine, and your cotangent is the opposite of that, which is cosine over sine. So if you, these are the four building blocks that we use for everything, right? And then from that, you add these to it, and then you're actually got a pretty powerful set of trig identities to work with. All right, so we have 1 minus cosine squared. Figure that out. Well, if we look at this right here, this first one right here, sine squared theta plus cosine squared theta equals 1. Well, I can get 1 minus cosine squared theta out of this if I just subtract cosine squared theta from both sides, right? And so I get 1 minus cosine squared theta over here, which is matches this. So whatever's on the left side, which is sine squared theta, is what I can put in here and substitute for that. So I'm going to do that. Sine squared theta, all right, for the top. And then the bottom, let's rewrite tangent theta. Remember, I'm always thinking in terms of sines and cosines, sines and cosines. So let's write that as sine over cosine. Don't worry about the fact that you have a fraction down there just yet, all right? Because it might take care of itself and it might not, right? So here we go. So we get sine squared theta over this. So let's simplify that now. So we have sine squared theta over sine squared theta, which is over cosine theta. So we've got a complex fraction here. So if you're not sure, well, can I cancel these two? I'm not positive. And what happens if I do? I got this cosine kind of buried in the denominator. How does that work? So just think of this in its root form of what it actually is. This is a division problem. This is sine squared theta divided by this down here. So let's just write it like that. All right, sine squared theta over cosine theta. And now let's remember our keep change flip, right? Keep change flip. So keep this first one, sine squared theta. We rewrite this as a multiplication. And then cosine moves to the top, and that sine squared theta moves to the bottom, which is awesome because they cancel out, leaving you with a lonely cosine theta. So that whole mess just translates to cosine theta. All right, so like I said, when you do these, sometimes you can go down a road that's a little more confusing than it needs to be. So I would suggest that always look for the easiest way to do these, right? And your if you're dealing with squareds, right, with squared terms, generally speaking, it's going to be something from this family. So just keep an eye out for that and try to have fun with these. All right, thanks for watching.